Hello, welcome to our next session in Chapter 8, Translating Power Functions. We have been talking about graphs, and now we're going to see how a graph is a visual representation of a mathematical relation. We had been taking a look at graphs and the absolute values of the graphs and how when you take a look here, you've got an absolute value of x is equal to y. When you graph that, you see here the absolute value of the x. Your x's are positive, but the y's are going to be negative or positive in both directions here. And then when you add 2, it shifts it up. The y is going to be shifted up. Or when you subtract 2, your y is shifted down. Well, that is the also when you have inside the absolute value, your x, when you add 2, your x is shifted over to the left. But when you add 2 inside the absolute value, then your graph is shifted to the right by 2 units. These are called translations. The translation of a graph of a function is a sliding of the graph without any rotating or resizing. And as you saw earlier in the graph just moved over 2 units either to the left or to the right, or 2 units up or down without rotating or resizing. Well, these functions, if we take those functions that we just saw and we had y equals x squared or y equals x cubed, then these are called power functions. And a power function is a function of the form y equals a x to the n power, where the base x is a variable while the exponent n and the coefficient a are constants. So, in other words, x is a variable that will change, okay? N and a are constants. N and a, those will not change. Now, let's take a look at an example here. Okay, example 1, it says graph the function y equals x squared. So basically, you can make a table, and in your table, you're going to put in the ordered pairs, x, and then x squared. And you can just randomly select several values for x, and then x squared, you calculate. If you had -3, you would get 9. If we use -2, we would get 4. -1 squared is going to be 1. 0 squared is still 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. Okay, so now we have x, values for x and values for x squared. And then so our x squared right here. Then we can plot those points and connect them with a smooth curve, okay? That would be -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. And then when you connect the dots, you get a nice curve, symmetrical curve, just like that. And gives us a smooth curve. This is called a parabola. A parabola has a turning point right here called the vertex. And the vertex V on the graph is here, the vertex is at 0, 0. This turning point represents the minimum value of this function, or the smallest value of this function y equals x squared. Okay, and that minimum value is at 0, 0. The vertex of a parabola can be used to determine values such as the minimum cost or maximum height in real life applications. So let's say that this graph is going to represent the cost of a merchandise, okay? And then so the vertex there would be the lowest value of that cost. Or if we're talking about the height of something, okay, maybe height in relation to your age or something, the vertex right there would be the maximum height or the minimum height, depending on where that vertex is on the graph. And we can use these graphs to be able to relate and read real life situations. Okay, so here the curve is called a parabola. Your vertex is the point, and here in this example, the vertex is at 0, 0. So let's continue with the next example here. It says to graph. This is on page 345 in your book. Okay, example number 2. And it says to graph the function y equals x squared, and then y equals x squared plus 2, and then y equals x squared minus 3 on the same coordinate plane. So on this plane, we're going to graph all three of these functions. Okay, y equals x squared plus 2, that's going to be the same graph, but just moved up because it's plus 2, y plus 2, it's shifted up 2. Now, if y is equal to negative x minus 3, this minus 3 is going to tell us where the vertex is going to be, and that's going to be at the minus 3 or negative 3 point. So there are the three graphs for each of these functions here. A translation of a function results when a number is added to or subtracted from either the input or the output of the function. So just like we saw earlier, the translation of the function shifts our graph either up or down some units, or to the right or to the left some units. Okay, that's the translation. That's when you're adding or subtracting from the function. In general, given y equals x squared plus k, the graph will shift k units vertically. So this plus k means that the graph is going to shift vertically up or down. Now, let's say we have y equals x squared. Here's our graph again, okay? But let's say that now we have x minus 2, this function squared. Well, how do we graph that? That means you are going to shift, okay, when it's dealing with the x here, so it's going to actually move the graph to the right 2 units. Okay, but if we have x equals, or x plus 3 squared, then because it's plus 3, you're going to actually move your graph over to the left. Look at that, okay, to the negative 3 on the x-axis. So if you notice here, okay, this is minus 2, you shift over 2 units to the right. Here, because this is plus 3, you're going to shift over 3 units to the left. So when it's minus, you shift to the right. When it's plus, you shift to the left. Given y equals x minus h squared, the graph will shift h units horizontally. The following chart applies to various types of functions. So, plus k after performing the base function means k units up. Minus k after performing the base function means k units down. Plus h before performing the base function means h units to the left. But negative h is going to be h units to the right. Okay, so this is a very helpful chart that will be a tremendous help for you as you're doing your homework problems and trying to figure out where to find the vertex. Okay, this is actually on page 346 in your book as well. Given y equals x minus h, the quantity squared, plus k, then your graph will shift. So h is for horizontal. Oh, you can remember that. H horizontally, k vertically, okay? The k sound. Vertical and k, okay? H horizontal, H for horizontal. So the vertex or the turning point of the function will be located at hk. So this value for h, and then if there's a value for k, that will give us the vertex. Now, let's take a look at this, okay? X minus 2 squared plus 4. So, what is our h and what is our k? Horizontal translation. This is our h, 2 units to the right, okay? Then vertical translation, this is our k right here, 4 units up. So our vertex now is going to be 2, 4. 2 from here and 4 from here. Now let's take a look at this function, okay? Think about where your h is and where your k is. Okay, the h, horizontal translation of 3 units to the left. Okay, it's positive, but you're going to translate to the left. And then vertical translation of 2 units, and we're going down because it's negative. Okay, so now our vertex is -3, -2. Now, let's say we have a graph of y equals x cubed. This can also be drawn using a table of ordered pairs. You can select points for x, and then you'll get x cubed. You can calculate that. The point of inflection of this graph is at 0, 0. If you have 0, x is 0, then your y is going to be 0, right? So this 0, 0, that's our point of inflection. When it's cubed, okay, this is our general graph of a function cubed. You're going to go up one direction and down on the other side. In general, the point of inflection, that's this right here, of the graph of y equals x minus h cubed plus k is located at hk. Again, you have hk, okay, that's still in a parabola, that would be the vertex, but here in this graph, this is